Today we're going to be programming this microcontroller to blink this LED light. Turns out this is exactly like why a mechanic will honk the horn to see if the battery is still working. Come on, let me show you. So let's write our code here. So the first thing we're going to do is we're going to type the word int. And do you see how that changed from black into this green? That means Arduino has recognized this as a specific command. So this is integer. So what we're telling the software is this is going to hold a number. So in our case, we're going to cycle pin 13. Now, pin 13 doesn't mean anything. It's just a pin. It happens to have a LED on it, so we can see when it turns off and on. But when we write our code, pin 13 doesn't mean stuff to us, it means stuff to the Arduino. So what we can do is we can assign our own name to pin 13. So when we type our code later, it'll make more sense to us. So we are going to call this board LED. So Arduino now understands that pin 13 is in a box called board LED. So what I think about this is I have a lunch box that I put my lunch in. I can change out that lunch later, but it is I eat from my lunch box. So now let's go down into the void setup. The void setup is just a one and done. We're teaching Arduino the basic rules. And when we get down to the next section, which is void loop, that is the section that's on repeat. Okay. So in void setup, we are going to do pin mode. And you see how it changed the color? And so pin mode is you tell it the pin and you tell the mode it needs to operate in. So in our case, the pin is the board LED. And then the mode is this is an output. Meaning that these pins are so powerful. For example, this pin 13 can either input or output. We're telling the Arduino, this is going to be an output. And we're going to end this statement with a semicolon. That's their version of a period. Now we're going to come down to the void loop section. So this is the section that'll keep running and running and running. So we are going to write something called digital write. And again, it recognized that as a word. And we are going to say, so this command, it's like kind of obvious what this means. So digital means off or on. You can't do anything in between. So it's either 0 volts or 5 volts. And write as when you read something is coming into the Arduino. When you write, things are going out into the world. So we are doing a digital write. So it's either off or on. And we are going to be sending that out into the world. So this is going to be they're asking us which pin it's going to be. So it's the board LED. And then it's going to be high, which is to say we want the full 5 volts going to this LED board on the board. Now we're going to tell it how long we want it to stay on. So we're going to use this delay command, which is a timer. It happens to be in milliseconds. So we are going to put down 1,000 milliseconds. And now we're going to write a command to turn it back off. So it's going to be digital write. And we're going to ask the board LED to be low. And we're going to add our semicolon there. And now we're going to turn it off for 1 second. So that is, of course, the delay, and we'll do 1,000, and we'll come and add our semicolon. And we're going to do a quick save, and let's upload it to the board. I'm going to verify all my code is correct. Oh, look at this. So this said I missed a semicolon. Thank you again. And we are going to select our Arduino board. Now we are uploading it to the Arduino itself. All right. So this is what makes this so remarkable here, this little blinking light. What makes this so nuts is that the first code you write is literally the way that programmers check to see if this board even works, right? Like this, not only is this like a useful lesson to learn, we learned about delay, we learned about digital write, we learned about the integer. We now have the thing to test to see if this board even works. Right? This is so crazy. So mechanics have this. Hold on, let me show you. Well, one of the things that a good mechanic will do is they'll beep the horn, and that will tell them if the battery is still working. So they now know that the battery, all the wires, and the button to the horn work. Now, it doesn't tell you everything, right? Because you don't know if the horn button's broken, you don't know if the battery wires are broken, you don't know anything. But when you hear the horn, you can deduce all of that works. And the same thing works with this Arduino. Like this little silly blinking light teaches us so much about what's going on, and it'll help us troubleshoot in the future. Subscribe so you don't miss an episode. And tell me in the comments below what sort of project you would like to do.